Okay, children. So this next chapter is polymers, and first I will explain the introduction I will give, and then we will go to the textbook. Okay. So polymers you must have learned in lower classes. Polymers are high molecular mass, large, long chain compounds. High molecular mass, long chain compounds formed by the reaction between monomers, small units, and the small units are called monomer. And so in polymer, there will be a number of smaller units combined, and the smaller units are called monomers. And since it is a long chain, n number of monomers are combined together, so they have high molecular mass. So already you know about polymers, isn't it? So the definition you understood, what are polymers? Polymers are made up of small units called monomers, and a number of monomers will be combined and you get a long chain compound. They are molecules, they are called polymers. Understood?
Yes, ma'am.
And so there are classification. The first topic is classification. You can classify polymers based on different categories. The first category is based on the structure. You can see the book. Based on the structure, one is linear. There will not be any branching. Linear polymers. And the second one is branched polymers. There will be branched. And the third one is cross-linked polymers. There will be branching and cross-linked. This in detail you will learn further. So here the question they can ask examples. So the classification based on the structure, how they are classified. They are classified into linear polymers, example polythene, branched polymers. See, there are two types of polythene. Polythene, you know, ethene, CH2 double bond CH2, that is the monomer. And when ethene molecules are combined, then you will get a polythene. So polythenes are of two types, low density polythene and high density polythene. Next, we will be learning in detail. Out of that low density polythene, they are branched polythene. High density, they are linear. Okay, so branched polythene example is low density polythene. And cross-linked polythene example is bakelite. You must have heard about bakelite. And so now for time being, you will be learning about these polymers later. So now for time being, this is the classification based on the structure. Okay, linear, branched and cross-linked. Now the next classification is classification based on the method of polymerization. Have you understood this much?
Yes, ma'am.
So any doubt you can ask, otherwise easy only. So first classification based on the structure, linear, branched and cross-linked. Now the next classification is classification based on the method of polymerization. So there are two types, addition polymerization and condensation polymerization. So addition polymerization, from the word itself, a number of monomers will be just added, and there is the second point. This addition polymerization will take place in the case of monomers having a double or a triple bond. Understood? So example, I will come to the board. Here, addition polymerization. Board is clear? Can you see the board?
Yes, ma'am.
Yes.
So, addition polymerization. So, I told you the monomer will be having a single bond, double bond or a triple bond. So, example, polythene. Polythene is from ethene. So, our monomer is having a double bond, isn't it? And N molecules, it is a long chain compound. So, N molecules of ethene, and the polymer, how do you write the polymer? You will remove the double bond, and then on both the ends n times. So this is an example of addition polymerization. Here, just the ethene molecules are added on. There is no elimination of any molecules, isn't it? Ethene molecule n times added. So this is an example of addition polymerization. Clear?
Yes, ma'am.
And there is another name, chain growth polymerization. Chain growth polymerization. Addition polymerization, that is another name is chain growth polymerization. Clear?
Yes, ma'am.
We will go to condensation polymerization. I will just write an example and then explain. So I am writing the condensation polymer nylon 66. This is an example of a condensation polymer. This is formed by the condensation reaction between hexamethylene diamine and adipic acid. Hexamethylene, see, methylene group is CH2. Hexamethylene, 6 times. Diamine, amine you know NH2, NH2. So this is the first monomer. Hexamethylene diamine and adipic acid. Adipic acid is a dicarboxylic acid, CH2, 4 times COOH. The monomers you understood? Hexamethylene diamine and adipic acid. It is a dicarboxylic acid. You see 2 COOH groups. CH2 4 times, COOH on both the sides. Clear? These are the monomers, and this condensation. There will be elimination of simple molecules. So in this case, elimination of water. So water is eliminated. So the polymer I am going to write CH2 6 times. Here I will write NH. Reason I will say NH, NH, CO. CO means CO double bond O. CH2 4 times, C double bond O N times. I will explain why this is happening. See, this is only a dimer, one molecule of hexamethylene diamine and one molecule of adipic acid. And so the dimer, what is the elimination of water? So NH2 becomes NH and COOH, OH from COOH, so NHCO. So the end also we should write. I didn't put NH2 here, I put H here. The meaning is here another adipic acid molecule will come. And at that end, I didn't put OH because you know that another hexamethylene diamine will come. Have you understood? This is how we will write the polymer. Here, once more I will say the monomers for nylon 66 hexamethylene diamine, which is CH2 6 times, NH2 on both ends, and adipic acid, CH2 4 times, COOH on both ends. Now condensation. This is condensation reaction. When they added H of hexamethylene diamine and OH of adipic acid, they are removed. Water molecule is removed. And that is why it is a condensation polymer. And so the polymer, how do I write this end, NH2, I will write NH only because polymer means this side also another molecule.
Ma'am, ma'am, how is the water molecule removed? Can you explain that again?
Water is removed. H of NH2 and OH of carboxylic acid. That is how the water is removed. So this is removed, so I put NH because H gone, here OH gone. So this is the binding part. Understood?
Yes, ma'am.
So the polymer when you write, there are n number of molecules. So this end, NH2, we will write H only. What is the meaning? Another adipic acid molecule will come here. H of this and OH of that will be removed. Isn't it? That is why I said n times. And so that end COOH, I cannot put a COOH because there another molecule of hexamethylene diamine will come. And so C double bond of N times. Have you understood?
Yes, ma'am.
So all of you write and see whether you are getting. First of all, you learn by heart. Nylon 66. These are all important polymers. Nylon 66, again we will be learning, but for explaining condensation reaction, I wrote it here. Again, when nylon 66 comes, I will not teach you again. So all of you write, learn along with me. First, the monomers. All of you learn now. First, the monomers. The monomers names you learn. Hexamethylene diamine, the first one. Methylene means CH2 group. Hexamethylene, CH2 six times. Diamine, one NH2 here, one NH2 here. First monomer you learn along with me. That is hexamethylene diamine. The second monomer is adipic acid. Adipic acid. Adipic acid. So adipic acid, CH2 four times, COOH, COOH. So you can see the first monomer, how many carbon? 6 carbon. Second monomer, how many carbon? 4, 5, 6. That is why the name comes as nylon 66. Okay, so you learned both the monomers, hexamethylene diamine and adipic acid. Two monomers are there. And so you will write both the monomers and then water elimination, because this is a condensation polymer. Water elimination, H from amino group, OH from the carboxylic acid. Clear? So you eliminate and write. So the binding will be NHCO bond will be there. And now when you write polymer means it is a long chain molecule. So you have to remove H from one end of NH2 and OH from the other end of the carboxylic acid group, put N times. Clear? So all of you write first. So after writing, tell me whether you have written or not. Any doubt? Still not understood? It is. I will go slow only because you should be able to write the polymers. And those who followed and those who could write, tell me. Okay. Ruchi done. Very good, Ruchi.
Done, ma'am.
Jai Kumar. Any doubt, Jai?
Video is not coming, ma'am.
Video is who's Jai? Why?
Yes.
Others video is coming?
Kind of blur, ma'am.
Why? Anybody? Okay now? Okay?
No, ma'am. It's not coming.
Now, others
Still
say
blurred, ma'am.
other. Amitabh, is it clear now? Can you see the equation?
Not properly, ma'am.
Ma'am, it's getting more and more blurred. I don't know why.
Others you say, Amitabh you leave. Other children are able to see. It's blurred. Why blurred? Okay, I will adjust.
Ma'am,
Hmm.
at times it comes blur and at times clear. I think it could be because of the internet fluctuation.
But everybody is having a fluctuation. Mine is not a problem. Now, is it because of the adjustment?
No, ma'am. I guess
Now is it clear, Amitabh? See, you can see the textbook now. I am explaining now. If it is not clear, Jay, see the textbook. Nylon 66 you take. What? No, ma'am. Completely blurred. Who is not able to see, you are saying? So children have learned. Many children have learned.
Done, ma'am.
Hmm? Okay, now I took it out of the board. So you can, Amitav, you can see the book and learn. Again, textbook, take, I will, those who cannot see, I will explain with the textbook. Okay, see page number 427, all of you, J, take page number 427. So condensation polymers, there the equation is there. I will explain with the textbook, those who cannot see. So the monomers are two monomers, hexamethylene diamine and adipic acid. So Jay, are you there? So,
Yes, ma'am.
so hexamethylene diamine, the formula you learn along with me now, hexamethylene. Methylene is CH2 group. Hexa means 6. So CH2 6 times, you see the book. And both sides NH2. That is the polymer, monomer. One monomer. And the second monomer is adipic acid. So adipic acid also CH2 4 times, COOH on both the sides. You saw on the book, textbook? So
Yes, ma'am.
then condensation, water will be eliminated. You see that water elimination, H of NH2 in the middle. The H of NH2 and OH of COOH. Water is eliminated. So the polymer is written. The end part we have to remove H. NH2 H we have to remove because another adipic acid molecule will come there. Isn't it? So H is removed. CH2 6 times in the middle, NHCO, CH2 4 times, then COOH, OH we cannot write because another hexamethylene diamine molecule will come. So N times, that is the polymer, and N water molecule will be removed. Have you understood now, Jay?
Yes, ma'am.
And Anand, Amitav?
Got it, ma'am.
Oh, so that is an example of a condensation polymer. Now, I did not tell you the definition of condensation polymer. So the definition is they are formed by the condensation reaction between molecules having a bifunctional or a trifunctional group. So now the in nylon 66, the monomers are having bifunctional group, isn't it? Two functional groups are there. In the first case, two NH2 group. In the second case, two COH group. Now you understood the definition? Got it?
Yes,
So we
Mm-hmm.
will go to the definition part. Okay, page 427. Addition polymers. Addition polymers are formed by the repeated addition of monomer molecules having double or triple bonds. You agree, na? In polythene we saw repeated addition of monomer units having double or triple bond. Underline. So they will ask you to explain. So the definition only is required and example. Addition polymers understood? They are formed by the addition reactions of monomers having a double or a triple bond. That point is very important. So last year they asked which type of compounds form addition polymers. Tell me which type of compounds form addition polymers?
Compounds
Monomers
having double bond.
having unsaturated group, double bond or triple bond, like that also they ask. Okay, so that is addition polymerization. Example, polythene.
What is this condensation reaction?
Condensation means some simple molecules will be eliminated. Here water is eliminated, na? That is
Yes.
condensation. In addition reaction, nothing is eliminated, they just added on. Polythene, nothing is eliminated, isn't it?
Yes.
That is the difference. Okay. So the definition of condensation polymer. Condensation polymers are formed by repeated condensation reaction between two different bifunctional or trifunctional monomeric units. Now understood? Nylon 66. They are bifunctional monomeric units. Two functional groups are there, isn't it? So You have to say that. You have to learn by heart the definition. They are formed by condensation, repeated condensation. Each word has a meaning. Repeated condensation reaction between monomers having bifunctional or trifunctional groups. Clear?
Ma'am,
Yes, ma'am.
what
Ah,
chain
ah.
growth polymerization?
Chain growth is addition. Another word for addition polymerization is chain growth. And for condensation polymerization, step growth. Another name for that. Clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Now the next term is, these terms are also they can ask. The next term is homopolymer and copolymer. Very important. So in the case of polythene, how many types of monomers were there? Polythene. How many types of monomers were there?
One.
One. So if the monomers are the same, then it is homopolymer. It is a homopolymer. In the second case, nylon, how many types of monomers are the monomers same? No, different, isn't it? So polymers in which different monomers are polymers formed by the combination of different monomers, they are called copolymer. Okay, and the reaction is called copolymerization. Very important. Homopolymer, monomers are the same. Example, polythene. Polythene is a homopolymer. And copolymer, the monomers are different. Example, nylon 6,6. Clear? Any doubt on that?
Yes, ma'am.
And you may be thinking, is copolymerization is in only this condensation polymerization? No, in both ways it is possible. Even in addition polymerization, copolymerization is possible. Okay, we will learn Buna-S, that time I will tell. Buna-S is an example of addition polymer, where
Ma'am, how do you identify homopolymers and copolymers?
the unit is the same, no? The monomers only. Monomers are the same.
But in the given, the example given 15.1.
Example 15.1. You can see that there is no, the monomer is CH2, CH, C6H5, double bond CH2. You can see that two different monomers are not possible there.
Only by seeing the question, we might
Question, you can see the polymer and understand. See, in that polymer given in 15.1, which are the two monomers possible? Not possible. Only one monomer, which is this one. I will explain that. Can you see the board?
Yes, ma'am.
Okay. So the monomer given, I will put the polymer given. CH2, CH, C6, H5, N times. Okay. So the only possible monomer is this. This is the only possible monomer. Here, how the polymerization, when you write the polymer, the double bond we remove. Okay. So in this case, how the polymerization N times, I will remove that C6H5 part, I will bring down and remove the double bond and this N times. It is the same thing. You can put it in any way. So this is the only possible monomer. Any other monomer? No. You cannot put C6H5 and CH2 double bond CH2. No reaction, isn't it? You cannot give benzene and that no reaction, isn't it? So this is the one. This compound is styrene. Styrene. And the polymer is polystyrene. You can write it down. You understood?
Yes, ma'am. Yes, ma'am.
Okay, all of you write it down. The polymer given is polystyrene. The monomer is styrene. Written?
Ma'am, how did you find the monomers in this?
So seeing the polymer, you can get it. Normally in the book, what is given, and that only will be asked. And at the end of the chapter, there is a table. From that table also, they will ask. So whatever polymers given, you learn. And here you write the polymerization reaction. It is styrene and polystyrene is the polymer. Okay? Only the polymers given in the book only they will ask. Clear?
Yes, ma'am.
Yes, ma'am.
Okay, so we will move ahead. Okay, see in the exercise, in the in-text, polymer definition I will give you. In the book it is not properly given. All of you write down polymers. What are polymers? Since the question is given in the in-text. What are polymers? Write the answer. Polymers are high molecular mass substances. Polymers are high molecular mass substances consisting of a large number of simple repeating structural units joined together through covalent bonds
Consisting of
consisting of a very large number of simple repeating structural units joined together through covalent bonds.
Ma'am, could you repeat once?
Okay. Polymers are high molecular mass substances consisting of a very large number of simple repeating structural units joined together through covalent bonds. Okay, written? Any doubt? Any doubt, children?
No,
No,
ma'am.
ma'am.
Okay, so we learned the definition of polymers and we learned two types of classification. The first classification is based on the structure, linear, branched and cross-linked, and one example you will learn. And the second classification is based on the methods of polymerization. And there are two types: addition polymerization and condensation polymerization. What is the doubt, Prashant? Tell me the doubt. Okay, I'm coming to that. Homopolymers, okay. Now audio is visible. Oh, here you can audible.
Yes, ma'am.
So the second type of classification is based on the method of polymerization. So there are two types: addition polymerization and condensation polymerization. Addition polymerization are addition polymers are polymers which are formed by the addition of simple molecules called monomers having a double bond or a triple bond. Example, polythene. Condensation polymers are formed by the condensation reaction between monomers having bifunctional or trifunctional groups, difunctional or trifunctional groups, and there will be elimination of simple molecules like water, alcohol, etc. Clear? Now Prashant asked me about homopolymers. See, polymers are of two types. Suppose the monomers are the same. For example, in polythene, the monomer is ethene. Ethene molecules only are added, isn't it? If the monomers are same, then it is a homopolymer. If the monomers are different, like in nylon 6,6, two different monomers are there, then it is a copolymer. Now understood, Prashant? Any other doubt you can ask, children? Since it is so it is not clear, don't hesitate. You just ask. I will explain. It is because equations are also there. Be very thorough. If it is not clear, you can explain. You can ask. I will explain any number of times. Okay. So that much is done. Now the next one, next classification. Next classification is based on the type of intermolecular forces. So I will just explain first and then we will go to the textbook. Okay. So elastomers, there are 4 different classification based on the intermolecular forces. So many questions from this type of classification also come. So elastomers, fibers, thermoplastic and thermosetting plastic. Out linear polymers, no. Example only, Naomi. Linear polymers, that they just showed the linear. When it is classification about linear polymers is asked, you will give example. That is enough. And example for polythene, you know, it is a linear structure, isn't it? So if you are writing polythene, then you will draw the structure. Bakelite for, branched, it is only the example you will write. Okay, note the diagram. Okay, coming to the next set of classification, next type of classification based on intermolecular forces. And I said there are 4 types: elastomers, fibers, thermoplastics, and thermosetting plastics. And you must have learned about thermoplastics and thermosetting plastics. Have you learned in lower classes? Yes or no?
Yes, ma'am.
Have you learned thermoplastics and thermosetting?
Yes, ma'am.
Say, have you learned?
No, I haven't.
Yes, ma'am.
So then, Jay only answered. Anant and all, where are you? Are you there?
No, I haven't learned it.
So it is, what is the
recall,
difference?
ma'am.
Amitav,
I couldn't recall it, ma'am.
you're telling something?
I couldn't recall the thing, ma'am. Thermo and thermosetting.
You learned. Okay. So some idea you have about thermoplastics. What is the difference? Thermosetting thermoplastics, that they soften on heating and harden on cooling. So you can reuse. If you heat also, it will come back, isn't it? Whereas thermosetting plastics, they will not, you cannot reuse. That is what you learned, isn't it?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Why nobody is responding?
Yes, ma'am.
Yes, ma'am.
How do I know that you are hearing? You are only saying that there is a problem with audio and video. When I ask you, please respond. Okay. So now the classification, elastomers. So elastomers are elastomer from the name itself. They are all the rubber polymers are coming under this category. So the weakest intermolecular force is in elastomers. So that is van der Waals force. The weakest is elastomers. So the examples, rubber and synthetic rubbers. There are synthetic rubbers like Buna-S, Buna-N, and chloroprene. These are all synthetic rubbers, isn't it? Neoprene, not chloroprene is the monomer, neoprene. These are all the rubber types are elastomers. Okay. Now coming to fibers. Fibers example, nylon. So the fibers are having the strongest intermolecular forces. And so that is one point. And then comes thermoplastics. Thermoplastics are having intermediate between elastomers and fibers. So the intermolecular force will be intermediate. And then comes thermosetting. And so one question will be, they will give you, suppose they give you bunaise, it is a rubber, you should immediately understand. Then nylon is a fiber. And polythene is a thermoplastic, not thermosetting, thermoplastics. So they will ask you to arrange in the order of intermolecular forces. Understood? That is one type of question. Mostly this is coming in this type. Got it? So coming again to the definitions, elastomers are rubber. You can remember like that. The weakest intermolecular forces, and fibers are the strongest. Thermoplastics, polythene, these are all examples of thermoplastics. They soften on heating and harden on cooling. And it is reusable. You can use it again and again. Thermosetting, after heating, it will not become the same plastic. Okay, so I take the book. Okay, take the book. And so here, elastomers. The question I said, mostly they ask you to arrange in the order of increasing or decreasing intermolecular forces. And in-text question is there that we will see. So elastomers are rubber-like solids with elastic properties. If they ask you to explain, you will just say that, okay? And the polymer chains are held together by weakest intermolecular forces. Explanation enough. And then example, all the rubbers, neoprene, bunaise, they are synthetic rubbers. We will be learning after some time. And fibers are thread forming, underline that and learn fibers, thread forming solids, the nylon threads, isn't it? Thread forming solids which possess high tensile strength and high modulus. And they can be attributed to the strong intermolecular forces like hydrogen bonding. So in nylons, hydrogen bonding is possible, and that also underline. And so then thermoplastics. If they ask you to explain about thermoplastics, these are linear or slightly branched long chain molecules capable of repeatedly softening on heating and hardening on cooling. They are intermolecular forces intermediate between elastomers and fibers. Polythene, polystyrene, and polyvinyls are examples. Then comes thermosetting polymers. They are cross-linked or heavily branched molecules which on heating undergo extensive cross-linking and again becomes infusible. So cross-linking will take place, so you will not get on cooling the same polymer. They cannot be reused. Example, bakelite. One example. Is it clear?
Yes, ma'am.
Yes,
Ma'am,
ma'am.
after fibers, which is this
Say loudly.
strongest?
I can't hear.
Ma'am, after fibers, what is the second strongest, ma'am?
Second strongest, you can say that the thermosetting. Okay. The least is elastomer.
Okay, ma'am.
Okay, now we will take that index question. You will understand what I am saying. Index question, page number, page 133. Take index question, page 133. The first question, the first one, the monomer. Can you identify the monomer of the first one? Which is the polymer? First one. Which is the polymer, children? Have you taken page 433?
That's
Ma'am,
966 and polymer is
hexamethylene diamide and
Nylon 66. Why only normally into answer?
hexamethylene and
The second, third, I didn't teach you. We will come back to it later. But the 5.15.4, next question. Classify the following as addition and condensation. Oh, that is also, there is another question, maybe in the exercise. Not that question. Maybe in the exercise. Index question. Arrange according to the 15.6. 15.6. Here is that. Ah. See, not the page 435. Take page 435. 15.6. That is the question. Arrange the following polymers in the increasing order of intermolecular forces. Have you seen the question? 15.6.
Yes, ma'am.
15.3 is also answerable, right?
No, I will teach that. I was talking about a 15.6. 15.6. Nylon 66, Buna-S, polythene. Arrange which is the weakest? Buna-S,
Buna-S.
because it is a rubber, isn't it? Weakest is Buna-S. Then the next stronger is polythene, and the strongest is nylon 66. Agree?
Yes, ma'am.
So the answer for the first one, Buna-S, polythene, nylon 66. Right there. Okay?
Yes, ma'am.
Chinmaya, very silent
Yes,
today.
ma'am.
No doubt, Chinmaya?
Yes, ma'am.
You understood, Chinmaya?
Yes, ma'am, I did.
Huh?
Yes, ma'am, I did understand.
Oh, okay. So, second question. Nylon 6, neoprene, polyvinyl chloride. Can you
Neoprene,
say
PVC, and
neoprene is a rubber, that is the weakest. And then comes
PVC.
polyvinyl chloride, and the strongest is nylon 6, isn't it?
Yes, ma'am.
Yes, ma'am.
This type of questions will come.
Ma'am,
Okay?
ma'am,
Hmm.
nylon 66 and nylon 6 is the same.
Hmm?
In the first question, it is nylon 66. Second is nylon 6. So both are same.
6 is different. We will be coming to that. 6 is different. Another. But anyway, it is a fiber. Nylon is a fiber. Terline is a fiber. So anyway, it is a fiber. Okay?
Yes, ma'am.
Ma'am, 15.3, third one.
15 point?
3.
Ah,
Third one, is
Ah.
it
yes.
1,1, 2,2 difluoro, sorry,
1,
tetrafluoro?
2 and 3 I will be teaching now. I didn't teach you. Only 1 I taught you.
Just trying to guess.
Okay?
Tetrafluoroethene.
Which one? That I will be teaching now.
Okay.
I didn't teach you. That is why I said first part, nylon 66 only I taught you. Okay?
Okay.
So we'll go to the next topic. So the classification is done. And now addition polymerization. Another name for addition polymerization is chain growth polymerization. So addition polymerization, there is a mechanism given, can be asked that mechanism, the formation of polythene. The formation of polythene is by free radical mechanism. Okay. So that mechanism, first I will explain and then go to the board. So it is a free radical mechanism. So formation of polythene, we should add a catalyst, a peroxide you should add. And the peroxide in the mechanism shown in the book is benzoyl peroxide. And so there are 3 steps. The first step is chain initiation step. The second step is the chain propagation step. And the third step is chain termination step. So first is initiation, chain is initiated, and the second step it is propagated because a large number of molecules are added. And the third one is chain termination step. This much understood? We are going to learn the mechanism of polymerization of ethene to form polythene. So the question will be that only. Explain the mechanism of formation of polythene from ethene. Understood this much? So there are three steps.
Yes, ma'am.
First, the chain should be initiated. Chain initiation step. The second step is chain propagation step. And the third step is chain termination step. Okay? So,
Yes, ma'am.
So I will go to the board, and if you do not follow, if you do not see the board, you tell me. If you if you cannot see also, okay, first I will explain on the board, you carefully listen, then come back to the textbook. I will come back to the textbook, okay? First, but tell me whether the board is seen, maybe because of my setting. Can you see?
Yes, ma'am.
Yes, ma'am.
Tell me, can you
Yes,
see the
ma'am.
board?
Yes, ma'am.
Clear? Amita?
Yes, ma'am. It's clear.
Okay. So I'm coming to the board, and tell me, stop me if you are not able to understand. The first step is chain initiation. So we are adding here, we are taking benzoyl peroxide, the structure I am writing. Benzoic acid is this, isn't it? C6H5COOH. So the benzoyl peroxide I am writing. So this is, see, there will be on both sides, there will be this C6H5CO group, and then in the middle, peroxide means 2 oxygen. So this is benzoyl peroxide. Understood? And so this will be, this is a free radical, phenyl. Phenyl means C6H5. Phenyl free radical will be formed. So this what happens, C6H5, C double bond O, free radical will be formed first. And that from that you will get a phenyl free radical. This is phenyl free radical. So from the catalyst, phenyl free radical will be formed. This much clear?
Ma'am, can you please repeat this, ma'am?
Yes, ma'am.
Tell me, is it okay?
Ma'am, can you repeat it again?
First step is, this is the catalyst we are adding. This is benzoyl peroxide, the catalyst. From the catalyst, you will get a phenyl free radical. That is the first step. Okay?
Ma'am, C6H5 C double
Yeah,
bond
you
O, that
have
is.
to learn by heart the peroxide.
No, ma'am, the second one. The second one, is that the free radical? What you have written after that, after benzoyl
This is
peroxide.
another free radical. Then finally, that also will give you phenyl free radical. This is
So,
what is going to initiate the chain.
both are free radicals, and the last one is phenyl free radical.
That only will initiate the chain. So from this is the catalyst. From the catalyst, you are getting phenyl free radical. Clear?
Yes, ma'am.
Yes, ma'am.
Now chain initiation step. Okay. So the phenyl free radical will react with our monomer. Monomer is ethene, isn't it? So the phenyl free radical is reacting with the monomer, and this C6H5 CH2, CH2 free radical will be produced. Understood? So it is just adding, and every step a free radical will be produced. Okay? Now, this is the chain initiation. A chain is initiated. Any doubt in this?
No, ma'am.
Chain initiation. Now the chain should propagate. So this is the first one. Chain initiation step. Now the second step is chain will propagate. So the second step, chain propagation step. So this, I will first say this.
Can you repeat the chain initiation once? I couldn't.
Chain initiation, the phenyl free radical will react with the monomer. And so C6H5, CH2, CH2 free radical. So the chain is started. The phenyl free radical is added to the monomer and another free radical is formed.
Okay, so chain will start over here.
Chain is starting. Now the chain will propagate. So one more I will see another. It will react with another of the free radical. And so see this, if two are reacting, you will get, sorry, another of free radical, not monomer, another monomer. CH2 double bond CH2. So it will be CH2, 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 CH2 free radical. Got it? This is only two or another monomer is added. So there will be n number of monomers. So this n number, many will be added. CH double bond CH2, so N will be added, but it is not a polythene, it is a free radical. This is the propagation step. You will get to this. End you will get. Understood?
Yes, ma'am.
Yes,
So
ma'am.
N will
Yes,
be
ma'am.
added, so in between you will put N. So still it is a free radical. So this is the chain propagation step. Got it?
So, ma'am, this whatever we have got, it still has the capacity to.
Free radical. So
okay,
end
okay.
we didn't get a polythene. When chain terminating step, then only we will get a polythene.
All right, ma'am.
Understood?
Yes, ma'am.
We'll go to the
Yes, ma'am.
chain terminating step. Vishnu Priya,
Yes.
any doubt?
Yes, ma'am.
What is the doubt?
No doubts, ma'am.
Okay. Okay. So now chain terminating step. Okay. So the initiation I will chain terminating different ways it can happen. So the one way is this free radical can, that is the different ways are there. One method only is given in your textbook. This one can react with another free radical, so you will get a C6H5 CH2 CH2 n times CH2 CH2. This is from the first one. From the second one again. CH2, 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 n times C6H5. Okay, chain is terminated. Now no free radical. Understood? This one will react with another of this. So I wrote here the first one, this much. First, and then the second one again, CH2, 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 n times C6H5. Chain is terminated.
Ma'am,
Ah.
can you explain the final product again? I didn't understand. How did you get the last one?
This is one radical. It will react with another of this. So two times I wrote. This much is from the first one. Second one from here I started. CH2, 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 CH2 n times C6H5. Got it?
Oh, okay, ma'am.
Understood?
Yes, ma'am.
So this is the final one. This is polythene. And you may be thinking, what about this phenyl group that will be released? This is one type of polythene. Okay, so that part is not given in the book. You have to write till here. This is polythene. Phenyl group will not be there. That will be released. Okay. Is it clear?
Yes, ma'am.
Doubts you
Yes,
can
ma'am.
ask children. If you do not understand, please ask.
Ma'am,
Hmm.
here the
Yes, Priyanka.
two free radicals are getting added, no ma'am.
Yes. There are
So-
different methods of chain termination. In your book, this one is given. So two free radicals are reacting. That means, see the first one I wrote, C6H5, CH2, CH2 endimes, CH2, CH2. This is the first one. Okay. Second one from here I am writing. CCH2, CH2. Then CH2, CH2 endimes, C6H5. Now understood?
Yes,
Ma'am,
ma'am.
ma'am, ma'am, am I audible?
Yes. Ask Anand.
What about the C6H5, ma'am? With at the end,
Huh.
like, will it remain there itself or will it get removed?
What?
Will it remain there at the end of the chain or will it be removed, ma'am?
No, I'm not able to understand. Okay, say now.
Ma'am, the
What is the
C6H5,
question?
the phenyl radical, right?
Not audible. Not
The
clear.
phenyl radical.
Free radical? Huh.
Phenyl radical, ma'am.
Phenyl radical? Huh.
Will it remain at the end of the chain or will it get
Yeah,
removed?
it will be released. End, na? End product. The book they have shown only this. So you write till this. It will be released. Polythene phenyl radical will not be there.
Okay, ma'am.
Okay.
Ma'am, the final step, chain termination
Ask.
step. So the product of chain propagating step, are we adding it 2 times?
The
Like,
product? I can't hear. Your voice only is cutting. Okay, say once more.
ma'am, the chain terminating step final is there, no? So in that, we are, it's that 2 free radicals are reacting. So is it that chain propagating step, whatever product we get, that we are using as
No,
the reactant?
I am not able to hear you. Voice is breaking. See,
Ma'am, can you just explain the last chain terminating step 1?
chain termination step, 2 free radicals combined. That part you understood?
Yes, ma'am. So the free radical which you are combining, that is the product that we get in chain
That is the
propagating
product.
step.
Product is polythene. And then you may be thinking what will happen with the phenyl group. It will be released. So that phenyl group will not be there. But in the book they showed till here. Na? You have to write till here. After that the phenyl group will go. So the end product is polythene. Only the ethene monomers were connected. Got it?
Yes, ma'am.
Clear?
Got it.
Is it
So,
okay?
ma'am, in exam, should we write with the phenyl group added or should
What
we
is
remove
there
the
in
phenyl
the
group?
textbook, that much only you will be writing.
Okay, ma'am.
Okay. So that is the free radical mechanism. The question is, explain the mechanism of polymerization of ethene. That is the question. So you just have to say first the phenyl radical will be, the catalyst is the peroxide. So from peroxide, the phenyl free radical will be formed. Then you will write chain initiation step. Then you will say chain propagation step. And the third one is chain terminating step. You will end with both the phenyl groups on the sides. That is enough. Okay. So in the textbook, what is given is enough. The end product. Okay. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. Any doubt you can ask? So far, whatever we learned, any doubt you can ask.
Ma'am, the free radical mechanism explanation you will underline or free radical mechanism explanation?
Not what a free radical mechanism.
Ma'am, I'll type.
What is the question, Naomi?
I'll type, ma'am. I'm not audible, I guess.
Now it is audible. Okay, type the question.